Question number 3. The square roots of 6 minus 8i can be expressed in the Cartesian form x plus iy, where x and y are real and exact. By first forming a quartic equation in x or y, find the square roots of 6 minus 8i in exact Cartesian form. 5 marks. So to find the square root of 6 minus 8i, we're going to equate it to x plus iy. And so we have then 6 minus 8i is equal to x plus iy, and all of that to the square. And of course, if we were to expand this, you're going to get 6 minus 8i is equal to, remember that I square is equal to -1. So this is just a quadratic expansion where we have x square plus 2i xy plus I square y square. So I square y square is basically minus y square. So we have then x square minus y square plus 2i xy, and all of that is equal to 6 minus 8i. So we're going to equate the real part to the real part, where we have x square minus y square is equal to 6, and the imaginary part, that is 2i, so 2xy, so I would say then 2xy, okay, is equal to 8, I minus 8. So if we were to divide by 4 by 2 on both sides, we're going to get xy is equal to -4. So that's my equation 2. So we can solve those two equations simultaneously. And so let's do that. Now we can, if we were to solve these equations, what's going to happen? So we can take equation 2 where we have xy is equal to -4, let y is equal to -4 divided by x. So we have y in terms of x, and take that, substitute into the first equation. So we're going to substitute, okay, y is equal to -4 over x into x square minus y square is equal to 6. And if we were to do so, we're going to get x square minus y, which is -4 over x square, is equal to 6. And if we simplify this, it's going to lead to this quartic equation. So here's our quartic equation that was required. And of course, we're going to have to solve this, which we can say x square x squared to the square minus 6, x square minus 16 is equal to 0. Now we can let say x square is equal to a. So what we are going to get then is a to the square minus 6a minus 16 is equal to 0. And solving this, we get the factors a plus 2 and a minus 8, which leads to a is equal to -2 and a is equal to 8. Of course, we're going to say that a was x squared, so x squared is equal to -2. We're going to reject this. You can take this, but it's going to take a long way. So then we also have x squared is equal to 8, leading to x is equal to plus or minus 2 root of 2, because the square root of 8 is 2 root of 2. So once we're here, we know the value of x. Now the complex root was actually x plus iy. So what do we have? We have x, one value of x is plus 2 root 2. So we have then the first root, I'm going to say 2 root of 2. All right, plus iy. And when x is equal to 2 root of 2, so we have y, which is equal to -4 divided by 2 root of 2. And this leads to, let's say root of 2, minus root of 2. So the first the first complex root is minus iy, so that's y is minus root of 2i. So this is my first one. And the second one now, when x is equal to -2 root of 2, of course I'm going to get y is equal to, then if you were to substitute this -4 divided by -2 root of 2, it comes to plus root of 2. That's okay, plus root of 2. And let us see now how we're going to try and put this into the into this here. So we have x is x, which is then -2 root of 2, and then of course plus your y in the y equal as root of 2i. So these are the two complex, the square roots of those of that complex number 6 minus 8i. So here we are. Take care.